let us begin our discussion of recurrent neural networks with the concept of a sequence. Sequences, like the name implies, are simply data that has some sequential aspect to it. This could be a sequence in time, but it can also be a sequence in space or in another abstract way. Mathematically, such sequences are represented with numbers, meaning that x2 comes after x1, x3 after x2, and so on and so forth. And similarly for the output. There are many types of sequence classifications or problems, if you will. Sometimes, for instance, many-to-many, you might have a whole sentence or phrase in one language where you are to produce the equivalent translation in a different one. Sometimes you have a movie review, which is many words, and you are to produce a sentiment, positive or negative. The main thing to understand about RNNs, as opposed to ordinary neural networks, is that the hidden layers are connected to one another sequentially. So looking at an unfolded RNN, so by unfolding we mean that this is simply an abstract representation of the same thing that you are seeing unfolded. You see that the hidden layer here feeds into the next hidden layer, and there are weights and computations that take place during the feeding. This is a somewhat general idea upon which many variations can be made. For instance, you can feed also the output into the hidden layer, or you can feed the outputs one to the next one. And all of this is part of a more general idea where you can create whatever graph you think will be best for the problem in hand. But sticking to the idea of RNNs, these are some variants that are commonly seen. One challenge that is encountered with some of these architectures is that the learning becomes unstable and the gradients grow out of control, which, since we are using gradient descent, is extremely problematic, or the gradient vanishes, in which case, again, gradient descent does not proceed. For that reason, some variations have been developed, such as the LSTM. Now, when it comes to actually implementing the RNN, the steps are as follows. So first, load the data as usual, and then, in the same way as in the NLP lessons, we still perform processing of text. So cleaning it, in this case, we find unique tokens, all in order to make the learning more efficient, but also, as discussed, in order to vectorize the input. The syntax for RNNs is as follows, where you use the NN package of PyTorch. And you can see here some variations. If you wanted a GRU or an LSTM instead of an ordinary RNN, you would use these lines here instead. And you can see we specify the input size, the hidden size, number of layers, pass in our input x, and eventually produce an output. And of course, nothing prevents us from using several layers. So for instance, here we have first the embedding part where we vectorize, then an LSTM, a type of RNN as discussed, and then we can activate if we wish, and we can do this twice, so 2 hidden layers. We have our training loop, evaluation, which are all familiar from previous lessons. So now you have an understanding of what is meant by sequence and how general of an idea it is, covering time series and language and so on and so forth. And the idea that an RNN feeds information sequentially, and you now know the syntax for implementing it in PyTorch.